I would like to introduce our speaker tonight, John Briggs. There is, as Kathy mentioned, a PowerPoint presentation, and then John will be with us and he'll answer any questions that you may have afterwards. I've known John for many, many years, back when he was first starting his beard. It's quite a while ago, and he was a member of Skyscrapers for quite a while, and the thing that we all really appreciated about John was his vast knowledge of astronomy equipment, his interest in the antique telescopes and other aspects of that, and his ability to kind of collect antique telescopes and find them in places that many of us never even would have thought of looking in. And he's amassed quite a collection out in his home in Magdalena, New Mexico. You perhaps have seen him on a recent episode of Hoarders on the Learning. I'd like to extend a really warm skyscraper welcome to John, and thank you for joining us tonight.
Thank you very much. It is very much my pleasure. I'm proud to say that even from the long rural distance of New Mexico, I still maintain my skyscraper membership. And I've been on a lot of Zoom meetings starting since August. I only tuned into this odd Zoom world, but I have never till this moment attended a Zoom meeting where I've simultaneously seen so many old and dear friends, because it's really pretty cool, because I really enjoy it. But in any case, being with you right now. And just to introduce the presentation very briefly, in August, it was my introduction to Zoom. I had an opportunity to speak for a meeting of SPIE, the Society of Photo Optical Instrumentation Engineers, and it's a big organization. It's well funded because they have a lot of connections with aerospace industry and everything, but a good number of people in SPIE have roots in astronomy, optics, and telescope making, and a past president of SPIE named Joe Houston has attended Stellofan and all kinds of things. He really knows things that interest us too. So it was thanks to this fellow Joe that I prepared a talk about what we're doing here in New Mexico with the sort of crazy telescope museum I've started. It's very informal. And so the presentation you're about to see was really prepared for SPIE. We are recycling it. And some of you I know have seen it already once before, but thank you for attending again. And that's why there will be certain references to other speakers and other aspects, because the presentation was created for this other event last August. But I still think you'll like it, and I look forward to speaking with everybody chaotically at the end of the presentation. So let her rip, Kathy, and I hope it runs well.
I thought I'd help set our location here. Magdalena is maybe best known for being the closest village to the Very Large Array radio telescope that's about 20 miles west of us along Route 60. This is very rural New Mexico. We have wonderfully dark skies. And by the way, this photograph was recorded by Bob Fugate, my friend, who is the other speaker in this session. Many of the best photographs in my presentation are thanks to Bob's photography. The Lyceum Building was built in 1936 as a WPA project. It was originally a school theater and gymnasium, but by about 6 years ago, it was no longer in use, and I was able to acquire it with a vision of it being shop space for working on telescopes and optical parts. I'm a semi-retired instrumentation engineer, and I've simply been nutty about telescopes all my life, having grown up as an amateur astronomer. The Lyceum is also the informal headquarters for our local astronomy club, the Magdalena Astronomical Society. Well, let me take you inside. I always feel like being a little apologetic. It's not exactly a standard museum environment. It's kind of like a warehouse, or maybe like an artist's studio, part workshop, part still lecture hall. Somewhat disorganized here and there, but visitors, everybody seems to enjoy the informality of it, and perhaps they feel comfortable. There's a certain charm in the casual style, and for that I'm very grateful. There sure are a lot of telescopes. I mean, it's a little mad. It's a telescope twilight zone, but we have a lot of fun. Some of the telescopes are modern, but many are historically quite interesting, quite old. And there's a lot more here than just telescopes, as I'll illustrate as we go along. Many of the instruments were built by famous makers. Some of them are really old. This one here was made by Henry Fitz of New York City. It's a 6-inch refractor, and it was probably made about 1855. Many of these older instruments are beautifully signed. Many also are dated. I've been collecting these things over a lifetime. Surprisingly, though, many of the things you see now in this collection have actually been given to me relatively recently. I guess I don't hesitate to share my enthusiasm for this stuff, and it comes back at me in certain ways. While some of the instruments are historic, some of our equipment is quite new. This astrograph is actually used by students and visitors and friends. It's a very modern instrument. In fact, Bob Fugate, our other speaker in the session, is a particularly active user of this instrument for wide field celestial photography. Some of the telescopes are very specialized. This is a transit instrument, a semi-portable transit instrument from about 1884. It was originally at University of the Pacific. It was used for either timekeeping, or if you knew the time, you could determine the celestial coordinates of transiting stars across the local meridian. But the mechanical workmanship in this thing, made by the Fouth Company in Washington, D.C., just extraordinary, exquisite, really mind-boggling when you have a chance to look at the details of an instrument like this. Some of the instruments are professionally made, but some are amateur-made, homemade. This kind of exotic instrument is a Schiefspiegler, an unobstructed reflector, about 4.5 inches aperture. It uses 2 spheres, but the aberrations cancel out. The image quality with a telescope like this is quite exquisite as the light kind of zigzags through it. Exotic instruments like this, of course, are a lot of fun. Some of the instruments are simply passing through the Lyceum as refurbishment projects. That's the case with this big one on the left there. It's a 9-inch refractor. It was made about 1915 by the Lohman Brothers Company in Ohio. That's me on the lower right. So beyond just displaying stuff, occasionally we are really working on stuff. We have a corner electronics lab and another corner room with a modest machine shop. Here's the 9-inch refractor leaving the Lyceum with a new paint job. We also installed a new microprocessor-controlled micro-step motor drive to track the stars, and it turned out very nicely. When you think about it, this instrument would have been, I guess, contemporary with something like a Model T Ford. Here's the complete telescope as recently installed only about a year ago at Roundup River Ranch in Colorado, a kids camp. This thing it's big. When pointed to zenith, that lens is 15 or 16 feet above the floor. So it was a big project, but I was very, very proud of it. Very proud to see a fabulous old instrument actually back in use, doing what it's made for and what it really will never wear out doing, educating people, youngsters, seeing the rings of Saturn and things of that nature. This instrument is in the Lyceum collection, and it's a future refurbishment project, but I'm showing it to you in some beautiful pictures I have as it was originally set up in the early 1950s. It was built by an amateur astronomer in California, George Carroll, but George Carroll was not your average amateur telescope maker. He was an amazingly talented man, had been very active as an early aviator, barnstorming pilot in the early 20th century. But anyway, by the 1950s, with an increasing interest in astronomy, he built this telescope in his garage as a donation to Westmont College in Santa Barbara. It's a 16-inch Newtonian Cassegrainian. David Dvorkin, a historian of astronomy at the Smithsonian Institution, grew up as an amateur in California and knew George Carroll, and describes how his work became legendary among telescope makers out west. And Carroll, in fact, became a research engineer at Lockheed, and also on the side became a professional telescope maker as a home business, and is actually best remembered for his solar instrumentation. We have another 16-inch amateur-built reflector at the Lyceum. It was made just about 20 years after Carroll's 16-inch. And you see it here, and I regret the photograph doesn't begin to do it justice. I'm hoping there are some optical designers listening to this presentation who will recognize the name of Donald Dilworth. This instrument, Dilworth built as a young man in his basement in Massachusetts. It's a Dilworth relay telescope. It has all spherical optics. It's to first order, it looks like a tubeless Cassegrain, but it's not a standard Cassegrain. When Don finished this project, he brought it to a convention of amateur astronomers and telescope makers in Vermont. There was hundreds of people there over a long weekend camping out, and the telescope created a sensation. I remember because I was there as a young teenager. The master of ceremonies pointed to this instrument and he said, "Someday that telescope is going to be in a museum of modern art." Well, it's here at the Lyceum now, thanks to Don's generosity. And the Lyceum is not exactly the Met in New York City, but we sure are proud to have it. The optically, by the way, the secondary mirror is actually a Mangan mirror. The reflecting surface is on the back side of a refracting element. There are also relay lenses inside the Cassegrain light baffle. And it was a design that Don simply whipped up himself. The simplicity of the tools that he had when he fabricated this in his basement was part of the astonishing story. It really was a stupendous thing. Well, at the Lyceum, we have artifacts all over the place, even hanging from the ceiling. Those big color prints on the wall, I'm proud to say, were all recorded with that modern astrograph that you saw a few images back. The big telescope hanging there on cables is actually a 13-inch refractor that was made in 1868. And of all the artifacts present here, this refractor is probably historically the most significant, but I'm going to explain that a little bit later. You know, when we got this building, we did not have running water. It took a while to restore the building. This is showing the powder room that we have outside the inner restroom. On the wall of the powder room, we have a very heavy bookcase. It had to be heavy because the volumes are so weighty. It's a set of Royal Greenwich Observatory observations going back to the early 1820s. See, I'm not fooling. We're actually as proud of the library we have as we are of the instrument collection. The core of the historical library was donated by Swarthmore College. Swarthmore, until recently, had Sproul Observatory on campus that had run for a century, old-style astrometric observatory with a 24-inch refractor, but a fabulous collection of observatory publications and early journal runs. But when they shut down that observatory because they had a new facility on top of a science building, the library was up for grabs. And making the long story short, we were able to move it here and save it as a collection. And we're very proud and very grateful to have it. Now, on top of the bookcases there is yet another a very unusual optical design amateur-built telescope, but it's a Shoopman medial refractor. It's a 10-inch aperture refractor. The optical design goes back to the early 20th century. It has perfect achromatic correction. It was made by Michael Maddie and James Daly, both opticians retired from MIT Lincoln Lab. And if you are interested in optical design and for some reason have not heard about the astonishing Shoopman design that offers perfect achromatic correction thanks to having another one of these Mangan correctors in the light path, well, it's possible, though not that many people necessarily know such a thing exists, as an unobstructed refractor with a single element objective, but nevertheless perfect achromatic correction at the final focus. That's what it is. Well, besides all the hardware in the library, of course, the other thing we have here are people, collaborators. Here are two fellow members of Magdalena Astronomical Society with one of the ongoing projects. They're standing with the Newtonian cage for a 37-inch telescope under construction. Behind them, in front of the bookcase, actually hanging on ropes, is the wiffle tree arrangement for supporting the 37-inch mirror. This will be a giant Dobsonian telescope being assembled in collaboration with Wheaton College of Norton, Massachusetts. But it's just another thing among the projects we have going on. Well, obviously, you're seeing that we have a lot of artifacts at the Lyceum, and we've got a nice reference library. And we're having fun. It's all volunteer, by the way. But you might ask, well, what good is coming of this? Definitely the greatest good that we can serve is occasionally when we have interested groups come and we get to share knowledge and enthusiasm with this stuff and having the show and tell artifacts. So particularly when we get student groups, physics majors, high school students and summer programs, we're getting people like that to come and visit, and they're self-selected, and it's fabulous. When we have those folks, there's a reading that I happen to have discovered. You all might notice that's A. Michelson here in this picture. There's a reading for Michelson. And of course, he was the first American to win Nobel Prize in physics. He had a little book, Light Waves and Their Uses. Here's a reading that I think is important to share with students. Michelson wrote, "Too few is it given to combine the talent of investigation with the happy faculty of making the subject of their work interesting to others. I do not claim to be one of these fortunate few. And if I am not as successful as I wish I could be in this respect, I can only beg your indulgence for myself, but not for the subject I have chosen. This, to my mind, is one of the most fascinating, not only of the departments of science, but of human knowledge. If a poet could at the same time be a physicist, he might convey to others the pleasure, the satisfaction, almost the reverence which the subject inspires. The aesthetic side of the subject is, I confess, by no means the least attractive to me. Especially is its fascination felt in the branch which deals with light. And I hope the day may be near when a Ruskin will be found equal to the description of the beauties of coloring, the exquisite gradations of light and shade, and the intrinsic wonders of symmetrical forms and combination of forms which are encountered at every turn." It's just a fabulous quote. With Michelson's quote, we have a nice segue into this small artifact from the collection here. There on top of the stack of books, I'm sure many of you will recognize, that's a diffraction grating, a little holder. Now, of course, we couldn't always take diffraction gratings for granted. Back in the early days of spectroscopy, we didn't have spectrographs. Spectroscopy was a visual science. And this is a fabulous spectroscope from circa 1875. Look at the prism train in this instrument. It was made by John Browning in London, about 1875. It's a solar spectroscope, and it was not designed to be used mainly on the little laboratory stand that it came with. You'd separate it from the stand, and you'd attach this to a telescope. The tube going off to the right has a slit at the far end. That's where you'd focus an image of the sun. The light from the sun would be collimated and fed through this prism train, which has 4 prisms and 2 half prisms. So a total of 5 prisms of dispersion in that thing. Looks kind of like a scorpion's tail. It's segmented, it's linked together. The light then was reflected back through the same prisms, come out the bottom of the first dispersing prism it entered, and then it would enter the imaging telescope going off here at the top of this tube, an eyepiece to actually see the spectrum of the sun. And there'd be enough dispersion that if you looked at the hydrogen alpha absorption line in the red with this, with the chromosphere of the sun entering the slit, one could actually see solar prominences without the help of a total solar eclipse. The fascinating instrument, but we really don't have time to talk about it, but I just wanted to show this in contrast to that diffraction grating. Because it's the diffraction grating that I really want to talk about. Now, if you get the light just on it, you can see along the bottom of the little aperture there, looks like there's writing. Let's check it out. Now, I bet some of you have seen these old gratings and you're thinking, oh, well, he has a Rowland grating from the 1890s. Indeed, Rowland at Johns Hopkins made the best gratings in the world at that time, but this is not a Rowland. This is earlier. This is more interesting. Well, let's take a look. I've taken it apart. You can see that the grating is ruled on a blank about 2 inches square, and in fact, it's metal. It's not a glass substrate. It's speculum alloy, a mixture of copper and tin. Speculum goes back to the time of Newton, of course, even earlier, before reflecting telescopes, but it was speculum that Newton used before silver on glass optics became possible, more like 1850. Anyway, let's take a look more closely now what the inscription actually shows. Can you read it on the bottom? Lewis M. Rutherford, New York, February 1875. Now, having flipped it 180 degrees, we can read the other side, and I think it says 5,761 lines, 8,646 or something spaces per inch. This is an early grading. Okay, who was this fellow Rutherford? Well, he was an amateur astronomer in New York City. He was quite fabulously wealthy, but he was also a fabulously creative and dedicated scientist. And he was a pioneer of celestial photography, among a lot of other things in the history of astrophysics. And for a while, he was the finest source of diffraction gratings in the world. And he became so enthusiastic about the potential of diffraction gratings for spectroscopy that he manufactured them at some small scale, but actually distributed them apparently free to spectroscopists around the world. To explain a little bit about how this happened, I happened to have bumped into a book by an astronomer named H.H. Turner, who was at Oxford University. The book, The Great Star Map, published in 1912. Let me give you a little reading. It says, Rutherford set to work to measure his photographs systematically and soon found that they recorded the positions of the stars more accurately than the best apparatus would measure them. In using a micrometer screw, he found, though he had provided himself with the best one available, that its errors were sufficiently large to prevent his doing justice to the photographs. He therefore turned aside from his original project to the construction of a better screw, and ultimately made a screw so accurate that his attention was again distracted towards the completest possible test of its accuracy. This he found in the ruling of very fine lines close together on metal, several thousands within an inch, the result being what is called a grating, which can be used like a prism to spread the light out into a spectrum. This work was so engrossing that Rutherford never seriously returned to his original purpose of measuring star photographs, but many of his have since been measured. This right here is one of these screw-enabled devices called a measuring engine. This one was not made by Rutherford. It was made by the Gertner Company, William Gertner in Chicago, and it was actually the original measuring engine at Van Vleck Observatory in Connecticut, and it was used to measure celestial photographs to determine the parallax shifts of stars as the Earth goes around the sun. The stars most nearby us shift a little bit, of course, and that's the first step in the cosmic distance ladder. But however, to measure the photographs accurately enough to do this, you'd need fabulous machinery. And that's what Rutherford pioneered, but discovered the potential of diffraction gratings along the way. Meanwhile, his celestial photography was most highly respected. Now, finally, I can return to the telescope hanging from the building, because it turns out this was the Rutherford Telescope. This is the instrument that Lewis used to record photographs of the sun, the moon, star clusters before the motions of stars had ever been measured by photography before. This was ultimately donated to Columbia University, where Rutherford was on the board of directors, and it was used into the 1930s for ongoing astrometric observations. Among the things Rutherford did, he was the first person to publish a spectral sequence of stellar spectral types. His was a very simple one, and he didn't pursue stellar spectroscopy very far, but he was actually the first to publish such a thing. Another thing, even less well remembered, Rutherford, with this telescope, was the first person to photograph solar granulation. But a lot of historians of solar physics didn't acknowledge Rutherford's priority in this for historical reasons. I can't go into the details right now. But I was very lucky to have as a friend Dr. Jack Harvey of National Solar Observatory. He knew we had the Rutherford Telescope. Jack proposed we take it to Kitt Peak National Solar Observatory outside Tucson and take it into the McMath Solar Telescope Laboratory behind us there. That was the most convenient way to take the unmounted old refractor and illuminate it with a sunbeam and then see what we could get. Could we reenact Rutherford's claimed priority photographing the solar granulation in the 1870s? Well, the proof's in the pudding. Here's an image from our observing run. Now, of course, we had everything going for us in terms of a modern camera, an electronic detector, good seeing at Kitt Peak. But obviously, the 13-inch lens from 1868 was still works great. Fabulous lens. The granules, the convection cells in the apparent surface of the sun, the solar photosphere, each of them is about 2 arc seconds in diameter. And they have a lifetime of just a few minutes. The dark spot pair down the lower right That's you would a solar physicist wouldn't call that a sunspot. It's too small at this image scale. It'd be called a pore. So we had a lot of fun publishing the results, reenacting Rutherford's observation of solar granulation with the original telescope, and it was absolutely no problemo. Well, stuff around the Lyceum goes on and on. Let's take a look at this observatory refractor with a 5-inch lens. Now, the thing I usually highlight most about this instrument is it was used by Clyde Tombaugh, the discoverer of Pluto, early in his teaching career at New Mexico State University. However, the telescope dates back to more like 1910, long before Clyde's time. There's a plaque on it that identifies the maker, a Paris-born optician named Petit. But by the time this telescope was made, again, circa 1910, I think, Petit was operating out of Chicago. What's interesting about Petit goes back to the reference to Michelson earlier. Most people think of Michelson and the Michelson-Morley experiment, so famous in the history of modern physics. Guess who made the optics in the interferometer for Michelson's Michelson-Morley experiment? Petit. So if we have advanced students visiting the Lyceum, advanced enough to be intrigued with the Michelson-Morley experiment, how cool it is to be able to point this artifact out to them. Now, of course, what we'd like to be able to do is have this telescope set up outdoors, so as we have visiting students and tell them the story of Michelson, who he was, the experiment, at the same time actually using this telescope to do something like look at the rings of Saturn. Well, that's a way to make it really hands-on and quite a memorable lesson in the history of physics. Okay, my abstract for this presentation was maybe a little grandiose. I made reference to certain ascendancies. Let's try to finally deal with that stuff. This picture shows several cool refracting telescopes. They have in common that they were all made by a family in Massachusetts, Alvan Clark and Sons. Let's see. This one here, it's a 5-inch, was made in 1875. This one here is a 6-inch refractor made 1884. This one here is only a 3.5-inch. It turned up on eBay recently, but it is 1869. All of these were made by Alvan Clark and Sons, a family that began experimenting with telescope making in the Boston area in 1844. Their telescopes progressed quickly in excellence, but American astronomers in the mid-19th century could not quite believe that good telescopes could be purchased locally without importing them from Europe. Eventually, the family sold a telescope to a fellow in England, Reverend William Dawes, a very famous double star observer. Dawes admired the telescope so well that he publicized his satisfaction of it in English astronomical journals. And Dawes was so highly respected when American astronomers saw the Clark telescopes recommended abroad, they began to pay attention to Alvan Clark. So the Clark instruments were superb. And the proof of that was that altogether 5 times the family came to build the largest successful refracting telescope in the world. And their more common telescopes were signed like this one. It reads Alvan Clark and Sons, Cambridgeport, Massachusetts, 1895. Very beautifully engraved. There is a certain almost irrational exuberance for Clark telescopes among collectors. These things are like the Stradivarius of telescopes among collectors. But it was justified. And their pride of workmanship, of course, is evident in how they chose to sign them. Now, by the way, 1895 was just 3 years before the dedication of their greatest accomplishment, the 40-inch refractor for University of Chicago, dedicated 1897. Let's now talk a little bit about the ascendancy of American astrophysics. It was enabled by early American optical engineering, but so much of it was due to one man, to one astronomer, pioneering astrophysicist, George Ellery Hale, seen here at the spectrograph head of the 60-foot solar telescope at Mount Wilson Observatory, of which he was the founding director. But before Mount Wilson, Hale, as a young man, was the founding director also of this observatory, Yerkes Observatory of University of Chicago. This is one of my favorite old-time pictures of the place. Check out the houses. Behind the trees in the extreme right side, that house, it was originally home of famous American astronomer E.E. Barnard. The house in the far distance, just to the right of the observatory, looks like a farmhouse. That was the home for many decades of the famous stellar spectroscopist William Morgan. More recently, the home behind the trees was used by Nobel Prize-winning astrophysicist Chandrasekhar, otherwise known around the observatory as Chandra. So Yerkes came to have a fabulous history, way beyond what we can describe now. But in its beginning, it was due to Hale, and it was due to the availability of a 40-inch objective made by Alvan Clark and Sons family. So many things flowed from Yerkes Observatory. You have to see it. You have to visit and see it to appreciate it, to believe it. What a lot of ornamentation, huh? You might wonder, was so much of that necessary? Who can tell? It was certainly inspirational to the people who were there. They meant business. You step inside Yerkes Observatory, and there's obviously no question that they built it to be a great and significant place. Long after Hale had left Yerkes for projects in California, he returned for what proved to be his last visit there. But he was in the company of a younger astronomer who recorded what happened. Hale was always in a hurry, and this time was no exception. He was late for a train. He came into Yerkes, he spoke with the director there, and had to rush out to catch a train back to Chicago. He was out the door, but realized he hadn't taken the time to step up and simply look at the 40-inch refractor. So he turned around. He went back up in the building and ran up to the top of the stairs and went through the door down there where those visitors are. And he looked up at the telescope for a few moments and simply he uttered, "Noble instrument." And then he ran out and caught his train. Here's a rare photograph, although it's on the internet now and you can find it. But what it shows is the Yerkes lens and cell being worked on in the Alvan Clark and Sons factory in Cambridgeport, Massachusetts. Now, by the time this lens was made in the 1890s, Alvan and one of his two sons had passed away. The surviving son was Alvan Graham Clark. But he, in the late 1890s, was already quite elderly. So the optician actually most responsible for this lens was a fellow named Carl Lundin. Working with Carl was his son, Robert. The young man on the left in this shot is Robert Lundin. He lived into the 1960s, and I heard a lot about him. And eventually, I found out that his daughter was living in Austin, Texas. And I wrote to her in the early 1980s. And I told her how I was interested in her family's optical history. She wrote back to me. She said, "Dear Mr. Briggs, you brought back memories I haven't thought of in very long. My father worked long hours and didn't talk that much about work." I'm paraphrasing my memory of her letter. But she also said, "You know, I have some things in the scrapbook. I have no one to give them to. And if you're interested, well, here they are." That's how I got this photograph.
Wow.
Until then, there hadn't been anything surviving known quite like this. So it's of course it's exciting to have it. Here's one of my favorite contemporary photographs of the Yerkes scope. It's showing solar physicist Steve Tomczyk of Colorado's High Altitude Observatory. He was visiting to take detailed measurements and undertake a optical study of the Yerkes 40-inch. He's very interested in it because he anticipates soon, he hopes, building a 60-inch single element refractor as a solar chronograph and mounting it at high altitude in Hawaii. So many astronomy textbooks describe the big refractors as dinosaurs and dead. Nevertheless, if you talk to certain solar physicists, the idea of even larger lenses to enable very low scattered light observations is still something quite desirable to be considered for the future. So there was a fabulous ascendancy of American astrophysics in the later 1800s and, of course, through the 20th century. And Yerkes Observatory was just a stepping stone, but it was a stepping stone towards Mount Wilson. Here's the 60-inch reflector at Mount Wilson. Many people consider it the grandfather of all modern reflectors. The mirror to this telescope was begun in the basement of Yerkes Observatory. The blank for it was purchased by Hale's father and imported from France. That's actually me there as a younger man. I worked there as an observer in the 1980s, and I'm proud to have had that experience. Funny thing is that for all of George Ellery Hale's accomplishments, having been the founding director of Yerkes Observatory, the founding director of Mount Wilson Observatory, the discoverer of magnetic field associated with sunspots, arguably his greatest scientific discovery, he's probably popularly not remembered for any of those things as much as he is for the 200-inch telescope at Palomar that was named in his honor, because he was the visionary driving force for this project as well, although he did not live to see it completed. Isn't this a nice drawing by the architect? Doesn't the architecture just exude the monumental vision they had? creating this facility. Now, although we've got all the way up to Palomar Observatory, I want to take one other quick aside, and that is you might wonder, well, how did I get so interested in this arcane stuff? Well, one of the factors was that as a young teenager, starting in 1973, I attended this convention as a young kid. This is the Stellofan convention in Springfield, Vermont. And this, in fact, is the same convention where I first saw Don Dilworth and his telescope. This event has been running annually since the 1920s, and nowadays typically draws about 1,000 people. It is a fabulous experience for a youngster interested in science to come and discover what a strong community of interest that exists in subjects like this. You otherwise wouldn't even know as a kid in school. We don't have time here to talk about the charming pink clubhouse and the very unusual turret telescope observatory built in the 1920s. This shot shows the crowd gathered for the main lecture in 2012. But Stellofan is a kind of experience that, as a young person, when you attend it, it can become more important than Christmas. It's so exciting, so interesting. The opportunities you have to see and do things and engage with nature. As you might guess, there was a visionary responsible for building the Stellofan Observatory and initiating the convention that continues to influence the lives of so many thousands of people. His name was Russell W. Porter. And as a young man, he'd been an Arctic explorer. But he was an amazing Renaissance character. He could do so many different things. He saw a telescope in action on Boston Common as a young man, looked through it by paying a nickel or something, found the view so engaging that he had to have a telescope of his own, but he didn't have much money. He had been a student at MIT. So he simply made his own telescope, ground his own reflecting telescope. He wrote up the work in popular magazines, and it drew the attention of an editor at Scientific American, who consequently gave Russell Porter and the activities at Stellofan considerable national publicity. Russell Porter's broad talents came to the attention of George Ellery Hale, and Hale recruited him to join the team at Caltech designing and building the 200-inch telescope. So Porter consequently spent the final years of his life out in California, closely associated with Hale. And what Porter became most famous for were the extraordinary drawings that he created of the 200-inch telescope and Palomar Observatory. I think every one of these drawings has a human figure or more somewhere in it. What we're going to do is I'm going to quickly and silently go through a few of these, and you can play Where's Waldo if you want, looking for the people for a sense of human scale. Whoa, hey, wait. How'd this get in here? Oh, it's okay. No, this is supposed to be in here. Okay. Um, Let me explain. There was another artist, friend of Russell Porter, named Maxfield Parrish. He was incredibly popular back in the mid 20th century. My sister-in-law collects Maxfield Parrish prints. Is still well remembered for this sort of thing. Well, Parrish and Porter were friends. Parrish was aware of those cutaway drawings of the 200-inch. This is what Parrish had to say about them. If these drawings had been made from the telescope and its machinery after it had been erected, they would have been of exceptional excellence, giving an uncanny sense of reality, with shadows accurately cast and well-nigh perfect perspective. But to think that any artist had his pictorial imagination in such working order as to construct these pictures with no other mechanical data than the blueprints of plans and elevation of the various intricate forms is simply beyond belief. These drawings should be in a government museum as standards, in a glass case, along with the platinum pound weight, yardstick, etc., to show the world and what comes after just what a mechanical drawing should be. Not only that, but the rendering is a work of art, exact and lifelike, and done with a delightful freedom of technique. I doubt if there are drawings anywhere which can in any way compare with these for perfection in showing what a stupendous piece of machinery is going to look like when finished. Their creation should be world news. Maxfield Parrish. Right on, Maxfield. Okay. The Lyceum doesn't have original copies of any of these Porter drawings. We're seeing them now through the courtesy of Caltech archives. You can find images on the internet easily enough. This one here is a little bit less finished. It's now recognized that this drawing was the one Porter was working on when he passed away. It was still on his desk. It's showing the Coude spectrograph of the 200-inch telescope. The spectrograph room is really the deepest inner sanctum of an observatory like that. Fabulously intricate. Now, folks familiar with modern optics, clean rooms, Newport tables, we can take these intricate environments more for granted today. But in the early 20th century, for example, the one at the 100-inch at Mount Wilson, there weren't so many examples of these kinds of places as there are now. So they're quite extraordinary to visit and to see, especially back in the day. Well, let's see. I'm going to try to point out that here, see, there's a grating holder. And because the grating was the heart of the whole apparatus, arguably the heart of the entire observatory, Porter chose to bring out the grating mechanism and its rotary table here. And notice there's the handle there too. That's what he was working to highlight in this drawing, because after all, this was the real inner sanctum. It was the instrumental mecca. The grating itself was like the meteoritic stone. Well, just to bring us back to reality, here's an image showing astronomer Horace Babcock there with the apparatus, and there's the grating table that Porter had highlighted. This image courtesy of Huntington Library in Pasadena. Well, we've spent a lot of time talking about Russell Porter and his famous cutaway drawings of the 200-inch, even though I don't have any originals of those drawings at the Lyceum. But there's some method to my madness, because the Lyceum is something of an archive. So let me tell you the story. There was a young Navy-trained optician working at Caltech on optics for the 200-inch. I believe, actually, they're optics related to that Coudet room. And Chester knew Russell Porter and went to visit him. And Chester expressed interest in mechanical drawing, and it was also quite clear that Chester Silvernail hoped to get a memento from Porter, who was famous for being able to improvise fabulous sketches of anything right on the spot. Porter replied to the young man, well, you know, instead of just giving you another drawing, how about I give you a lesson? So the result was this document, and we have it at the Lyceum. And that's because Chester, he went on to become a professor of astronomy at San Diego State and many other projects, and ultimately a senior optical engineer at Los Alamos. Also along the way, Chester became friends with Gene Cross. I bet many people listening to this know Gene Cross, optical engineer, senior optical engineer in California. Chester gave his papers to Gene Cross. Gene Cross recently gave a lot of his papers to the Lyceum. That's how I discovered the Silvernail collection among Gene's papers, including this little document here. To find the vanishing point of any system of parallel lines. Well, you can follow it along, and there it is, signed with the initials of Russell W. Porter, June 1947. But as a fellow telescope nut and appreciative person of Porter's genius, I'm very proud that this document survives safely. Okay, after all this talk, there is a test I'm inflicting upon you, especially if you ever want to come and visit the Lyceum. And the test is, you have to look at these two images of me, then and now. If you can correctly identify then versus now, you're welcome to come visit the Lyceum. Sure hope you do someday. But if you do, don't take it out on me if you break your foot on this artifact basically in the entryway of the facility in the corner. It's quite immobile without an engine hoist. And if you do come and you're curious about this artifact, maybe I'll tell you the story of how it happens to be here and how we aspire to refurbish it along with a lot of other things, and how crazily it came to pass to be part of the collection. With that little mystery in mind, thank you very much for your attention during this presentation.